Okay, welcome back to the chemistry review series. We are in Chapter 5, Thermochemistry, and we are talking about heats. We're talking about calorimetry. So this problem states the specific heat of octane is 2.22 joules per gram Kelvin. How much heat in joules is needed to raise the temperature of 55.9 grams of octane from 15.8 degrees Celsius to 48.6 degrees Celsius? Okay, so the first thing, we need to remember the formula given in the chapter. Q equals mc times delta T. That is, heat equals mass times specific heat times the change in temperature. And remember, the change in temperature is the final temperature minus the initial temperature. So this problem looks pretty straightforward. We have the mass, which is given as 55.9 grams. The specific heat, which is given as 2.22 joules per gram Kelvin. And we have the change in temp, which is 48.6 minus 15.8 degrees Celsius. Okay. So plugging all this into our calculator. Now, one very key thing that you really should do when working on these types of problems is making sure that your units cancel. This is something I always tell my students. You want to make sure that when you multiply these things, your units cancel. So, for instance, we have grams and grams in the denominator. Those cancel. But, as you see, we have degrees Celsius, and we're multiplying it, or we're dividing it by Kelvin. So you might think those units are different. So this brings up a key point. Note that the formula is delta T. It's a change in temperature. So note that so Kelvin equals degrees C plus 273.15. So note that because the conversion between the two temperatures is simply a shift on the number line, the change, if you were to have two changes, so per se 0 degrees Celsius to 100 degrees Celsius, the change between those two numbers is 100. Now convert those two numbers to Kelvin. So 373.15 minus 273.15. And again, you'll notice that the change is 100. So it doesn't matter whether if units are given in Kelvin or Celsius, as long as you're multiplying by a change in temperature, then you can keep either unit. You don't need to convert to Kelvin, because when you do that, you'll get the same change whether you use Kelvin or Celsius. So if you don't believe me, prove that to yourself by converting these two temperatures to Kelvin and subtracting them, and you'll get the same delta T. So we'll plug that into our calculator. So we'll get Q to be equal to 4,070 joules. So this is our answer, and the question states they want the answer in joules. So this is what we would report. Okay, plugging and chugging. All right, on to something a little bit more challenging. This is more of a concept question. So, which will require more heat? Increasing the temperature of 2 moles of octane by a certain amount, or increasing the temperature of 2 moles of water by the same amount? So they're asking in which case here. So we have C8H18 or H2O. In which case will we need more heat, more Q? Okay. And we can use this formula, Q equals mc times change in temp, or we can compare it conceptually, because we know that the masses for each, the substances, the amount of substance will be the same. So we know that the number of moles will be the same. And so we need to calculate something called molar heat capacity. Okay? So we need to figure out how much heat will we really be needing per mole Kelvin for each substance. Okay? So the molar heat capacity of C8H18, we'll need to use that number given above, 2.22 joules per gram Kelvin, but we also need the molecular weight of C8H18 because it asks us, because we need to compare moles to moles. Okay, so the molecular weight of C8H18 will be 8 times 12.01 plus 18 times 1.01. Okay, so the molecular weight of C8H18 is 114.26 grams per mole. Okay, so now we are going to simply do a conversion. So above 2.22 joules per gram Kelvin times, we'll just have to make that a little bit larger, 114.26 grams per mole equals 253.58 joules per mole Kelvin. So this is the octane molar heat capacity. So now we are going to do the same process to determine water's molar heat capacity. So the molecular weight for water is 18 grams per mole. And so as before, now this is a constant you should have memorized by now, 4.184 joules per mole Kelvin of water multiplied by 18 grams per 1 mole. Okay. You will get just multiply that out quickly. 75.3 joules per mole Kelvin. Okay. So again, you want to make sure, this is incorrect, this should be grams. You want to make sure that your units cancel. So looking over at the octane, our grams cancel. Oops, sorry about that. Well, okay, our grams cancel, and we'll have the joules per mole Kelvin, which is what we want. And likewise, our grams are going to cancel, and we're left with joules per mole Kelvin. So comparing these two numbers, will show us that octane will require more heat. Okay, octane will take more heat because it has a higher molar heat capacity. So therefore, it will take more heat to raise the temperature by the same amount. More heat per mole. Okay, thanks for watching. This was the conclusion of the second problem for calorimetry.